Hey everybody, in this video we're going to be working on the chapter 8 homework problems here. And yeah, let's dive in. So in our packet here we have the problems, and I'm going to do a snip of the problem out of my version of the packet here. But just a reminder, you all have this in your class packet, is where you'll find those. And yeah, you'll be able to solve from there. So let's take a look here. We've got a company that purchased a copier for $85,000 on the first day of the year. So that tells us we can use annual depreciation for some of the problems pretty easily. The copier has an expected life of 4 years or 2 million copies. So this will be useful for straight line and double declining. And then our number of copies that we expect it to be able to produce will be useful for the units of activity method that we can look at. And so that's what we're going to have to do. We're going to do the depreciation over the life of the new copier with those three methods. And it tells us how many copies were made. And then we've got a table down here that we can fill out. And it looks like we don't need to do the accumulated depreciation. We just need to show the depreciation expense, I believe. Yep, for each one of those values, essentially. So without further ado, let's create this table to begin. I think that's the best place to start. And so I'll kind of walk you through the process of just setting this up, and then we'll work through the actual calculations as well. Okay, so first thing, I think I'm going to take off the grid lines. But I'm going to recreate this table. So I'm just going to type this into this here. And so again, what we're talking about with these DDB and the units and all that, those are the three different depreciation methods. Okay, so I typed one of those into each cell. Then I'm going to do make the outlines here, and let's do that same kind of thing for a table here. 1, 2, 3, 4. So we just need 4 years, and then have the total. Let's make that nice and aligned. And yeah, so straight line, units of activity, and double declining balance. And so let's put a few things in here. Let's just list out some items here first that'll be helpful for us in Excel, and then we can kind of link into these. I think that's kind of handy. That's how I like to do Excel, is just to get the data we're working with into its own cells so that it's easier to analyze and manipulate for formulas, etc. Okay, so let's say historical cost, or just cost. Yeah, let's just say cost is $85,000. That's what we bought. Let's say the life, and we'll say in years is 4, so 4 years. Life in months, then we can here's where it's kind of nice too. It's pretty easy math, but once it's in Excel, we can just multiply whatever the years in is times 12 to get us the number of months, so 48 months. Yeah, you know what? Let's go ahead and put the salvage value. Let's see if we can fit that in there. Salvage value of $5,000. These in as dollars. So now we've got cost, salvage value, life in months. Let's say total units, and we'll put the 2 million copies. What else do we have? Other data. Okay, and then let's say in 20x1, the first year, basically. we had 450,000 copies, 20x2. So second year, we had 600,000 copies. 20x3, we had 700,000. And then 20x4, we had 400,000 total units. And let's just put copies. I mean, we kind of, oh, it went weird. We kind of know that, just by setting up the problem, but I just like to, this is kind of a good practice for working with Excel anyways, just to sort of get all your variables in their own spot in a cell, and it's a lot easier to do analysis that way. So I think we've got everything we need to finish the problem then, and yeah, let's get started. Okay, so remember for straight line, it's going to be cost minus the salvage value, and let's just put that into, just to really make this clear, cost minus, I'm just going to say SV. Let's put this in as SV so we know what we're talking about. So that equals cost minus the salvage value is 80,000. So, pretty simple, but kind of nice just to have that clearly laid out. And so really important, since we bought this on 1/1, we don't have to worry about monthly depreciation actually in this problem. So figuring out the months is kind of irrelevant, but a good practice, I think, to get in for these kind of problems anyway. So the first year, so we have a full year's worth of depreciation because we bought it on the first of the year. It's got the 4-year life. And so we're going to take our cost minus salvage value and just divide that by the years. And then because we're doing so 20,000 per year, and yeah, that's going to be the same for every year. And so just a quick little Excel formula tricks, right? When you drag this down, it's going to start, as you can see, this is good. We want to have that the same for every year. But what happens is it starts dragging down. So now instead of the cost minus salvage value divided by years, now it pulls those variables. What was C16, C17, when you drag it down, becomes C17 life divided by C. And you don't want that anymore. So how you fix that problem, if you want to have the exact same formula but still be able to drag it down, is you want to put dollar signs around the formula to lock it in so it stays on those cells. And a shortcut for that is just to hit F4 once you click into the spot in the middle of the thing so you can see the dollar signs it puts in. And then similarly there. And you can actually click F4 and it does a bunch of different dollar sign configurations, and that'll lock it in a certain direction or not. But for this one, we want the cell, so we just lock both those in. So you can do this manually as well once you understand the formulas, but doing F4 is just an easy way to do that. And then now we can drag down and it's going to keep that same exact, you can see C16 divided by C17 formula just stays the same in every cell. And that's what we want. And then if we add all those together, we get $80,000 of depreciation expense after the 4 years of life. So 4 years is done. And if we took our accumulated depreciation here, over those full 4 years, you can see that, our cost. And I'm going to do that just to kind of show. And then let's say cost and net book value, which is cost minus depreciation at the end of the life. So we'll say total depreciation is 80,000. The cost is the 85,000. Let's put extra little space in there. And so if we want to see what the net book value is, then you take your cost minus the total depreciation over its whole life, and that's where we end up with the 5,000, which is the same as the salvage value, which is what we're trying to show. We want the salvage value basically means when we get this thing fully depreciated, it will still have this net book value amount that will show up on our balance sheet. We don't think it'll ever go below 5,000 basically. Because what we're saying is even if it has a 0 useful life left, we can still sell it for 5,000. Okay, and yeah, let's look. Oh, and here's another thing that would be good for us to do or to put in. Let's put in another space here, and let's say depreciation expense per unit. So when we're doing units of activity, one good practice is to take our cost minus salvage value again, and just instead of dividing that by years, we're going to divide it by the total number of units. And it gets kind of small here, but it's 0.04. So again, cost minus salvage value divided by the number of units. So what we're saying is every unit of depreciation gets us or every copy, I should say, makes 4 cents of depreciation. So here we don't know, the life and the years and months and all that doesn't matter. It really just comes down to the units of how much these things right here, basically. And so, 4 cents per unit. And let me make sure I got all this in here correctly. Oh, interesting. 80,000. Okay, let's see if this works. Okay, so we're going to, for the first year, so what we're going to do, every one of these years is going to have depreciation expense per unit as a variable we want to do. So we're going to, again, click F4 to lock that cell. And then for the first year, we're just going to click into that cell. And we're going to want that to update as we drag down through the years, so no need to change anything there. Okay. And then we end up, let's take our total. And what I think is going to happen, and that's what I was expecting to happen, is that we're going to have more depreciation in the final year than we actually can take, basically. So we're not going to depreciate beyond 2 million units. And if what you can see, if we add all these units together, it's 2.15 million, basically. And so that's the sum of all these. And so essentially what we're saying is we thought it was only going to last us 2 million units, but in reality, we actually got 2.15 million units out of it. And so how we're going to account for that, we can't go beyond 80,000 because that's our formula. So instead of the 16,000 in the final year, we're just going to limit that to arrive at the 80,000 total. So we have to do some kind of manual adjustments to the final year, essentially. And so, so what I'm saying is this is what it would be, 16,000, but in reality, we need to only take what's left. So if we add all the previous depreciation so far, that would get us 70,000 up to this point. That would be the accumulated depreciation expense. But we can only take 80,000 in total because that's what we've determined through our calculations. And so I'm going to take the total of all that we've done so far minus, I guess I did that backwards. How about C19? So the 80,000 is the most that we can depreciate minus all the other stuff we already did. So instead of 16,000, which is what we would have calculated, once we hit 2 million copies, basically, we just stop taking depreciation expense. And in essence, we say this thing, the equipment is fully depreciated at that point. So again, instead of having 16,000, we had to manually limit the amount of depreciation in order to reach the total accumulated depreciation of 80,000, which again leaves us the, I'll do it here, right? So that's our cost. And then the net book value is just doing that same formula. Excuse me. And so we end up at the same place, which using straight line or units of activity or any method, we're going to arrive at the same net book value of the 5,000 because that's what we determined as an estimate of what we were going to have it in at as the salvage value at full depreciation. Okay, so let's do our double declining method. I think the double declining method is kind of handy just to have its own table, essentially. And let's set that up. So let's do DDB. Let's say year beginning. You know what? Let's actually put the year over here, just make it a little, give us a little more space. So year 1, 2, 3, 4. And then get a little more space here. We'll say DDB table, Talby. Okay, so we've got year, beginning book value. 2, we'll say the, oh right, yeah, so 2 divided by the life in years. That's basically the rate, the depreciation rate. We'll say portion of year. This is kind of a good one. We did to have this in here. If we don't need it this time, but I'm going to leave it because I think we'll probably have some other problems that will use this same type of format. And I'm going to leave this because we can use it in the future if we do have a partial year depreciation. That is handy to have as just a component of your little kind of formula / table. Okay, and then that equals depreciation expense. And then we've got accumulated depreciation and ending. I'm just going to say ending book value. Let's do that. Let me just kind of get these cells good. Okay. Cool. Okay, so now we've got this table kind of built out. Let's work through this and calculate what our totals are. And it's going to use a lot of the data that we have up here. Okay, so remember when we're doing double declining, we do cost, but we don't care about salvage value. We're going to have to adjust for that at the end of the life, basically kind of like we did for units even, but I'll show you that here when we get there. Okay, so then we're going to do 2 divided by the life in years, so that's 4. Again, let's lock in this formula by hitting F4, clicking into the C18 and clicking F4. And then we can just drag that down so that we continue to have that same formula. The portion of the year was 12 out of 12. If we want to just put it that way, let me see what a good fraction, just to make this. Yeah, there's a way to show this. Up to 1 digit as. Well, anyway, let's say portion. How about this? How about a percentage? That's probably good. So it's 100% of the year, because what we're saying there is that we bought the thing on the very first month of the year. If we had bought it halfway through the year, this would say 50% basically, right? Or if we bought it 3 months in, this would say 75% of the year because we had it for 75% of the year in service. Okay. So again, we take our beginning book value times our life, or our depreciation rate, and the 2 is just because it's double declining, so it's always 2 divided by the life in years. The portion of the years just 100% because it's full years worth of depreciation. Our accumulated depreciation is the same as our depreciation expense because this is the first year. And then we take book value minus the accumulated depreciation to get an ending book value. Then we carry that ending to the beginning of the next row. Then we do the same thing. You just multiply the beginning book value by those same 2 factors. The accumulated depreciation, then you add those. It's an accumulation of all the depreciation expense throughout its life. And then we take beginning again, very beginning, the total cost, 85,000 minus the accumulated depreciation there. And then again, we carry down the ending book value, do the same formula. So we're just multiplying those all out. Accumulated depreciation then becomes what we had prior in accumulated plus the current year's worth. And then we take beginning, historical cost minus the accumulated. And here's in the last year where I think we're going to have to do a little special adjustment because, again, we can never go below our total cost minus salvage value. We can never go below 80,000, or in other words, our accumulated depreciation cannot exceed 80,000. So if we were to just do the same method that we had been doing and adding that to accumulated depreciation, let's see what we get. Well, see, we don't even get enough. That's so interesting. See, we don't even get enough depreciation basically to get to the total. So we're a little bit under based on double declining. And so this is where we have to do some manual different adjustments. And the way that we can make this work then is to say our depreciation expense needs to be a little bit higher, basically to get us exactly to 80,000. So if we take 80,000 minus the ending there, it gives us 312.5. So we can just go into this formula, put some parentheses there so it does the order of operations right, and then just add 312.5, manually add extra depreciation expense, and that will bring up our ending accumulated depreciation to 80,000 exactly. And then our ending net book value becomes 5,000, which is what we're expecting. Okay, so that's the funny thing about the first year. Sometimes you have to do a partial year, but then the final year, sometimes you have to do manual adjustments for these kind of things to get it to be exactly what you're trying to end at. Because sometimes, especially with like the double declining, or it could be with the units of activity, it just kind of gets a little wonky in the last year. And so you have to do these manual type adjustments, like this one we did and this one, in order to get it to exactly end up with accumulated depreciation equal to cost minus salvage value. Cool. Okay, and then let's just add in let's go up here and just drag this formula down. This is just taking all of our amounts there, sum those up, and we can basically just do the same formula. I just wanted to show that on each of these methods, we still end up with a net book value of 5,000. And again, just as a reminder, what this means on our balance sheet, if we were to look at this on our, if it said assets and, there's cash and everything else, but when we got to the depreciable asset part, we would see maybe copier and then accumulated depreciation copier, right? So remember, that's how it works on our classified balance sheet, or, just any balance sheet as it breaks out with the asset and the contra asset. So we would end up with $85,000 cost, the contra asset of accumulated depreciation total of 80,000, and then net book value in our assets section of our balance sheet showing $5,000, right? Because we estimated that it was worth $5,000. We estimated that we'd be able to sell it even when it's fully used up for our business purposes of the $5,000. So I just wanted to highlight that because that's what this all means essentially, from tying it all together. So I'm going to kind of undo that. It's a little bit of just extra expounding on what's happening here, but that is problem 8.1. I think that was, yep, that's all we need to do. So great. All right. Well, thanks everybody. I'll end this specific video here, and join me in the next video for 8.2.